so we continue our discussion of limits and rational expressions and that sort of thing. So we talked a lot about rational expressions. Now we're actually going to talk about this idea of a limit. And so looking at the graph, and so the limit is simply where is the graph going as it gets to a certain point. So this asks us to determine the limit as x approaches negative 4. So this is limit as x approaches negative 4. So again, it's if we're looking at what happens at the graph as we get close to x equals negative 4. And in most cases, it's very boring. If it's a part of a continuous graph, we'll talk more about what that means later, it's just where is that point. And so it looks to me like that limit is simply 0. That if I look at evaluate that point at negative 4, I get 0. Where it's interesting is where something else happens. So generally, limit as x approaches a of f of x equals just f of a. Whatever that number is, we just plug it in and we get the number. And then there's special cases. The first one here we see at negative 5. At negative 5, it looks like we're going along, as x gets to negative 5, we're going along okay. We get a hole. Which means f of negative 5 does not exist. So there's not a value at negative 5. But the limit as x approaches to negative 5 of f of x is just where that is. And so it's still the y value or the f of x value we would have there is at this spot, which is actually also negative 5. This is negative 4, the next line is negative 5. So the value would be negative 5 if we were on that. So that's our answer for that one. All right. So generally boring. The only time we generally ask it is if there's something weird going on. So again, f of x at negative 3. So at negative 3, again we have a hole. Where's the hole? So limit as x goes to negative 3 of f of x is just equal to that, what the function would be there if there wasn't a hole. So it's negative 1. At negative 1, we have a disconnect. So another special case. We have a disconnect. We have a function that's broken up. We actually have a value, f of negative 1. There is a point there. It would be negative 4. But when we see the other side, it's not there. So we mentioned earlier, we looked at things from the left and from the right. The limit of f of x, let me write it more clearly, as x approaches negative 1 from the left of f of x. So on this side, as we get there, it's going to what the value is negative 4. The limit as x approaches negative 1 from the positive side, so coming from this side of f of x, sorry, I'm losing you there. Let me just zoom out a little bit so we can get the entire width of the page. This value, if I'm walking along it this way, I actually get positive 1. If these do not match, then the limit as x approaches -1 of f of x does not exist. So again, the big difference in between what we just saw a minute ago and this one is, on this one, the limit as we approach -3 from the left, f of x, equaled the limit as we approach -3 from the right. Both of them, even though we were coming to a hole and there wasn't a value there, both of them, from the left side it was heading towards -1, from the right side it was heading towards -1. So those matched up, we have a solution. In this case, they don't match up, we don't have a solution. So we'll see more of that in part C. The limit as x approaches 0, f of x, again, as we get to 0, there's not really a problem. At 0, from this side it's going to there, from this side it's going to there. So this one, the limit as x approaches 0, f of x, is just 2. Nothing special. The limit as x approaches 2 of f of x, again, we run into the situation. We come from this side, we're heading towards 1. We come from this side, we're heading towards -2. So this one does not exist. Not only does the limit not exist, the function also does not exist there because both of these are holes. So there's actually no function there at all. Again, we can have parts from each side. The limit as x approaches 2 from the negative side was equal to 1. And the limit as x approaches 2 from the positive side, f of x, was -2. But those things did not meet at the same place, so we don't have a limit.